Okay, so today we're going to prove the Pythagorean theorem, which states that if triangle ABC is a right triangle with right angle C, then AC squared, so AC squared, plus BC squared is equal to AB squared, right? So we can label the side AC as B, right? The side opposite of angle B as little b, and this represents the length AC. We can represent the length BC as A, the opposite of angle A, and we can represent the hypotenuse as C, like little c, opposite of the angle C, right? And this is the same thing as proving A squared plus B squared is equal to C squared. Now, what I'm going to do is I'm going to draw a diagram. So I'll start the proof. And we're going to consider the following diagram. Okay, so here's our diagram. We have the length of the shorter leg is A, right? Which is what we had here, BC. The length of the longer leg is B, which is what we have here. And the length of the hypotenuse is C, right? So remember, we can show that AC squared, right, plus BC squared is equal to AB squared if we can show that A squared plus B squared is equal to C squared, right? Because AC, right, is equal to B, and BC is equal to A, right? And then AB is equal to C. So if we can show this, then we can show this. So now we have our diagram here with those four congruent right triangles where we constructed it in a way where we have this big square right here, right? And we have this small square. And we know this is a square because the sum of the acute angles of a right triangle are 90. And we know that this angle here corresponds with this angle here, right? So we know this angle, right, plus this angle is 90. And we know that this angle here must be 90 as well because the sum of these three angles has got to be 180, right? So that means this has got to be 90. And that same reasoning goes for all of these other ones, making this a square. And of course, all the sides are the same, right? So that's the justification for why it is a square in the middle. So now let's go ahead and move on to the proof, right? We want to prove that A squared plus B squared is equal to C squared using this, right? Using our right triangles constructed in this fashion. Okay, so now we know that the area of this big square, right, is equal to, so we know the area of a square is side times side. So that means we know the length of each of these sides is A plus B. So it's going to be A plus B squared, right? A plus B times A plus B. And we know, of course, if we distribute this, right, we get A squared plus A times B is AB, B times A is AB, so that I'll have 2AB. And then B times B is B squared. Although we can represent this big square in another way, right? We know that the area of this big square is the area of these four triangles here, right? Plus the area of this smaller square. So we also know the area of this big square is equal to 4 of these triangles, the area of these triangles here, right? Area of those triangles, plus the area of that small square, right? And we know each of these triangles has an area of 1/2 base times height, where, of course, the base could be maybe A, right? And the height could be B, right? And we know that B is the height, or A is the height, right? Because it is the perpendicular distance between the vertex and the base, whichever base you choose it to be, right? So we know that this is 4 times 1/2 AB, right? Plus, and the area of the small square is C squared. And we know that 4 times 1/2 is going to be 2ab, right? 4 times 1/2 ab is 2ab plus c squared. Now I know the area of the big square, right? This area is of course equal to itself, but we got it represented in two different ways. But this area is the same, so we can set this equal to each other, right? So this implies that a squared plus 2ab plus b squared is equal to 2ab plus c squared. And then we can do 2ab minus 2ab to give us our result that we wanted. A squared plus b squared is equal to c squared. And notice, all we assumed was that this triangle here was a right triangle, and we're able to construct a diagram with that right triangle to get to our goal, that the leg squared plus the leg squared is the hypotenuse squared. And that is the proof of the Pythagorean theorem.